Let's take a look here at 153. I think this is a good skill check for a couple of things. Graphing, area under the curve, and then, estimating is always a good idea. So the first thing we want to do is f of x equals 3x cosine x, and approximate the area from 0 to pi over 2. So 0 to, let's say pi over 2 is there. So I guess we don't need this out here. I think for what we're going to do, understanding a couple of things would probably be a good idea. One, what happens at 0 and pi over 2? At 0, the graph's going to be 0 because 3 times 0. And at pi over 2, it's also going to be 0 because the cosine of pi over 2 is 0. So then what's going to happen in between, x is going to be increasing, and the cosine of x is going to be increasing until pi over 4. So I might go to my table and get some values from there. Now, I think if I'm looking for some good values around here, I might actually divide it not into my classic pi over 6, pi over 4, pi over 3. I might actually divide it evenly, pi over 8, pi over 4, 3 pi over 8, and then pi over 2. Our reasoning there would be, you are going to have some, one of our methods for estimating area is using rectangles, and if we're using rectangles, we'd like to use same bases. So a base of pi over 8 would be ideal. So then let's take a look. In my table at pi over 8, I think I get 1.1, let's round up, 1.7, and then looks like 1.4, and then back down to 0. So something along the lines of pi over 8, 3 pi over 8. So not quite a half a circle, because it's definitely just a little bigger on this side, but not far off, I guess I'd say. 1.1, 1.7, and this should be 1.4, so we could sketch that just a little better. Two different methods to approximate the area. One would be, I guess I would expect most kids to say one would be, left-handed rectangles. This would be one, this would be one, this would be one, and this would be one. It's actually not a bad idea, probably. Let's take a look at what happens there. So left-handed rectangles, they touch the left side of the, and each one of their bases is pi over 8. So it's pi over 8 times a height of 0 for this guy right here. Pi over 8 times a height of, now I've got to go on my table, 1.1, 1.7, and then, so this is 1.1, 1.7, and then 1.4. Now I definitely demonstrated 1, 2, 3, 4 rectangles, but we actually didn't use the last height, of course. So what happens when I do that calculation? That actually gets me 1.65, which is really close to what it should be. So that was a left-handed rectangles. I could do right-handed, but maybe instead I'd like to demonstrate, how about some trapezoids? Let's see what would happen with trapezoids. We should recognize that if I do trapezoids, which I guess that one's really a rectangle, trapezoid, trapezoid, and then triangle, I guess, did I say rectangle? I do have even bases, so again, each base is pi over 8. The area of a triangle, or let's call it trapezoid, base 1 plus base 2 divided by 2 times height. Now I times the height way out in front. Base 1 plus base 2 over 2 plus base 1 plus base 2 plus, again, base 1 plus base 2. If we run that all through our calculator, funny, we actually get like the exact same thing. So maybe I should have gone a little smaller, maybe with just some easy triangles or something. But I guess really what I wanted to look at was, do we understand what area under a curve looks like? Can we use different methods? Very important calculus. Calculus, finding the area under the curve. Very important calculus. Concept. Come on back.